My name is Kainson Mononye, the computer engineer. Today we are going to discuss the operating system process model. There is a typo, sorry about it. So, what is operating system process model? I'm trying to explain in a very simple way, and I'll also try to be very brief. So just follow along and you'll understand the operating system process model. So, a process model is a hypothetical description of how the operating system works. So the point is we are trying to explain the operating system. There is a number of models that can be developed. For instance, an operating system can be looked at as a collection of files. It can be looked at as a collection of system application programs or a very big complex software. But a process model looks at the operating system as a collection of processes. So operating system equals collection of processes. What is a process? A process is an instance of a running program. So if you install Microsoft Word in your system, that you have a program. But when you click and start working on Microsoft Word, that is a process. So a process is made up of a number of threads. We'll get to that in a minute. I've just made the screenshot so I can show you in Windows 7. Using the tasks manager, you can get to the resource manager and you can see the list of processes running in your system. A process have a name, the process ID, and the description status, of course, is running, and the process is made up of a collection of threads, and the impact on the CPU is also given here. Let's proceed. Now, a process is made up of a number of states. Basically, there are three states, but theoretically there are five states. So what are the states? If a process is running, it means it's being executed, it's using the CPU time and resources, it's running. Then a process is ready when it is in the queue waiting for the scheduler to dispatch it to the running state. Okay, so when a process is in the ready state, nothing stops it from running except that the scheduler have not put it to the running state, or it have not got the opportunity or a time slot to run. A process is blocked when it was running, and due to either event waits or an interrupt, mainly event wait. When it's waiting for an IO, it might be blocked so that another process might run while it waits. So a blocked state is also called a waiting state. We have new, a process is just created, and exit, a process just terminated. There is illustration. Process can move from new to ready, admitted into the ready queue. It can move from ready to running, dispatched by the scheduler. When it completes execution, it's terminated. If it's running, it can be interrupted and it moves to the ready state. If it's also running, it can be stopped when it's waiting for an IO or event from the keyboard or from some other input device, and it moves to the ready state. When this IO event is satisfied, you'll be waiting for a key press, and you give the key press, it moves back to the running state. So this illustration of the process states. We move to the transition. I think I've explained this. It can move from new to ready, can move from ready state to the running state. The scheduler chooses that process to execute next. Can move from the running back to the ready state. Okay, when it has used up the time slot. Running to blocked, is waiting for something from the user or from the keyboard or from some input device. It moves from the blocked state to the ready state when the event have occurred or has been satisfied. Now, how is process created? When you start up your computer system, a process is created, and several process of course is created. When there is a system call, when you issue a command, uh, then a process can be created. Sometimes the system can actually create processes, and that's why if you look at the list of processes, you can see plenty of them. Many of them are system processes, and a few of them are user processes. When user creates a new process by running an application, a process is created. We also have a batch job. Then we have events that cause process termination. We have a process exit. Normally, maybe it completes the task. There is an error. There is also a fatal error. Then another process can also issue a kill, or can kill a different process, and it gets terminated. system shutdown can also be part of it. Process creation steps, I got this from my lecturer. This is the steps. I didn't see this I didn't see this procedure in any textbook, but I got it from my computer science operating system, principles of operating system. I think this is CSE 801. I can't remember, but these are the steps, and it makes sense to me too. How the operating system loads the code and data into memory from disk for sure. Then it creates and initializes the PCB, process control blocks, is a data structure. I think I'll come to that later. Then it creates the first thread for the process. It calls that. It provides initial value for the thread and then makes the process known to dispatcher. So maybe you just get used to this, but it's from my lecture and it's very good. How a process is implemented? A process is implemented using a table, a process table. Okay, so this table has several entries, and each entry is called process control block. So you have 10 processes in this table, so we have process control blocks in each entry of the table. So that is how a process is organized. And a single process control block represents an entry in the process table equals a single process in the system. So let's proceed. A process control block. What is contained in a process control block? So these are the lists. Take note of the ID of the process. A process ID, very important. You have the register contents. Then you also have list of open files or handles. Then you have the status of devices needed by the process and every other thing. Process context switching. What is it? If a process is running and it is interrupted so that some other process can run temporarily, maybe a higher priority process can run temporarily, and then a process can be stopped temporarily, and that is what is called context switching. You switch the context from one process in the process table to another process while it saves the state of this current process, and then when this process that interrupts it completes, it switches back. So what happens? It occurs whenever the CPU moves the execution from the currently running process to another process, and the following steps are carried out. I outlined about 6 steps there, so get used to them. You have the context is saved, okay, PCB is updated, okay, and PCB moves to the either ready or blocked and so on. So just get used to these steps, but just take note that in the next slide I have this diagram illustrating the process context switching. You have 2 processes. We have the process running, process 0, that has been running, okay, it's been running for a time, and at some time there is an interrupt, okay, such that process, a different process has to be run, that is process 1. So what happens is the state of the process control block for process 0 is saved, and then control is shifted to process 1, while the process 0 that was running before remains idle for a time, and everything about it, the state of this process 0 is saved, and then after process 1 executes, the operating system moves the control back to process 0 and it continues from where it stopped. So there is a little I can tell you about the operating system process model. I hope this has been informative for you. I would like to thank you for viewing. Don't forget to subscribe to my channel. You can also share this video with your friend. Leave a comment below. Tell me what you don't understand and I'll be there to explain to you. Thank you once more for viewing.